this video, I'll show you how to use these two theorems that are in the notes. First one is rational root theorem. It tells you that if you have a polynomial like this and the first coefficient is 1, the biggest power coefficient is 1, and you have a rational root, so a over b is a 0 of p of x, I'm assuming that a over b is reduced, meaning that a and b don't have any common factor, then b must be plus or minus 1, and a should be a divisor of the constant term. Right, so that's the first one I'll use. I'll also use the second part of the remainder theorem, which says that if you have a polynomial, then x minus c divides p of x, so that's one of the factors in the factorization of p of x, exactly when c is a 0 of p of x. Alright, so we're going to use these two to factor a polynomial that a priori I would know how to factor. So let's say I want to factor p of x, which is x cubed plus x squared minus 4x plus 2. So for a polynomial like that one, usually you would expect to have to use factor by grouping, but that doesn't work in this case. And so I'll show you how to use these theorem to figure out how to factor it. So the remainder theorem tells us that if we could find a 0, then we would have one factor at least, and then we could figure out the rest later. So we need to find a 0. Now the rational root theorem tells us that if we want to find a 0, we have to look at the divisor of a 0. So in this case, our a 0 is 2, and so the potential R would be divisor of 2, so I have 1 and 2, and then negatives as well. So the 4 potential zeros that I could have 1, minus 1, 2, minus 2. How do I know which one works? I plug them into p. So p of 1 is 1 plus 1 minus 4 plus 2 is 0. Alright, I found one. You can try the other ones. What I'll do is, since I have one, I already know a factor here. I know that x minus 1 is a factor, and I'll divide the polynomial by x minus 1. I'm going to get it quadratic. I can see if I can factor it. If I can't, quadratic formula will tell me what's going on. So here, I found 1, 0. I found 1, 0, x equals 1. Now I'm going to divide p of x by x minus 1. Now there are two different ways of dividing long division of polynomial. There's a French notation and an English one. They do exactly the same thing, so do whatever you're comfortable with. I'm going to use the French notation for this one. X fits x squared times an x cubed, so I get x cubed minus x squared. I subtract them, I get 2x squared minus 4x. I need 2x to get to 2x squared. I'm going to get 4x plus 2x, so I get 2x minus 2x plus 2, which fits minus 2 times. I'm sorry I'm a bit low on space, but this will give me a remainder of 0. So I'm getting that p of x is x minus, actually let me write it on the other board. Actually, let me finish. I'll write it again. X squared plus 2x minus 2. factor, I need to find other factors. I need to find how x squared plus 2x minus 2 factors. It doesn't factor over the integers, so it's not obvious. But what I'll do I'm going to use the quadratic formula to find the zeros. I've already found them, so let me just use them. So I'm getting minus 1 plus square root of 3 and minus 1 minus square root of 3. Alright, so I have my two other zeros. So that tells me that x minus each of them would be a factor. Well, that gives me 3 factors. And since my polynomial has a 1 in front, well, that's all I need to know. Alright, so if you're trying to find an eigenvalue for a matrix and you get a polynomial that you don't know how to factor, then find 1 0. You have one factor, you can divide, and then get something of a smaller degree, which hopefully you can do.